Hello, Environmental Policy 1 students. Dr. Conway here for Lesson 10 on the sound management of chemicals. It's at this point in our course now we switch from some of the ideational, institutional, structural, legal issues that we've been learning about, in which environmental policy people need to know about in our course to this point. Now we're shifting to a couple or three sort of problem areas, and thinking about coming to grips with these problem areas in context of the ideational structural process issues we've been looking at through the term thus far. And one of the major issues that are out there, obviously, is climate change. We're not dealing with climate change because there's so much going on with climate change, and there's so many other exposures to climate change. So we'll be concentrating on three other major areas, and areas that relate well to this program in terms of environmental management and assessment. Not that climate change doesn't, but certainly chemicals in soil and so on are very important aspects of this program. In environmental policy too, we get more of an opportunity to talk about some of the climate change issues as well. All right. But this lesson is about the sound management of chemicals. And this is an area that I've worked in for 20 some odd years, including negotiating international agreements in the field. So I just want to talk to you a little bit about the importance of sound management of chemicals, because if you look at the regulatory infrastructure for the environment in Canada, you will see that a very large proportion of environmental regulation deals with chemical-related contamination, whether that be through SEPA, and we already know what SEPA deals with, toxic chemicals, right? Whether the Fisheries Act as well deals a lot with chemicals, and there are other areas, health and safety legislation, and so on. So chemicals plays a very big role in regulating environmental health and safety across several departments, okay, within government and at all three levels of government, federally, provincially, and in municipal governments, which also now have their own chemicals management programs, such as in Toronto, that has its own chemical reporting protocols by regulation. Okay, so the sound management of chemicals is very important. So what I'm going to do is give you an overview of the issue of chemicals, intensification of society, and how we think about chemicals and the various types of chemicals and classes of chemicals that have to be regulated. Okay, so on that score, let's get started. You can see that. Let's describe what the sound management of chemicals is, because all regulation in the area of chemicals tries to encourage the sound management of chemicals. Okay, the sound management of chemicals is the application of managerial best practices to chemicals throughout their life cycle, so as to minimize and where feasible eliminate the potential for unintended exposure of people in the environment to hazardous chemicals. All right, now that's a phrase that you will see both nationally and internationally in international instruments, whether that be Stockholm, Basel conventions, or the strategic approach to international chemicals management, which I was involved with negotiating, and so on, because this is the principle of the life cycle management of chemicals, so that chemicals are used in ways that they are intended, and if they're not intended to escape to the environment, they don't escape to the environment. If people are not, our ecosystems are not intended to be exposed to these chemicals, then they shouldn't be exposed to these chemicals. And that's what regulation tries to do. It tries to control those factors of harm when we regulate for chemicals. All right, the notion of sound management of chemicals goes as far back as 1992 in Agenda 21, Chapter 19. It advanced the notion of the life cycle management of chemicals to include precautionary, anticipatory, and preventive approaches to chemicals management. And those issues are still prevalent today, whether it be national legislation or international negotiations. Okay. And policies applicable to the sound management of chemicals, including within Canada, have largely been driven by science. So this is a very science-intensive area of work in the sound management of chemicals. Most of my work in my career has been at the nexus between that science and policy in chemicals management, and in addition to climate change resilience, but a large part of my work has been in the area of chemicals. Okay. And we've seen how that has evolved. We already talked about local, regional, national, and international issues, and a lot of what's drove that transformation of environmental problems has been in the area of chemicals, right? Until climate change came along and biodiversity and so on. But most of the early international environmental negotiations were related to chemicals management, as early as 1984 with the Basel Convention on hazardous waste, which we're going to be talking about next week, okay? Science has improved the nature of our understanding of chemicals and the risks of chemical exposures, right? For carcinogenic properties, immunological properties, mutagenic properties, persistence and bioaccumulation, endocrine disruptors, and other properties of chemicals. Science has done a lot to drive this agenda since basically the 60s and Rachel Carson's Science Spring. All right, so if you look at the history of environmental policy, from the early days, 68 and then 72 when Environment Canada was formed, chemicals drove a lot of that, right? Chemical contamination, with that being the form of acid rain or eutrophication of lakes and rivers or any number of other issues. Chemicals drove a lot of the agenda, including all the way out to international negotiations, which was part of what your last short paper was about, okay? Our knowledge of chemical properties and associated health risks increased significantly through science. But ironically, prior to SEPA in 1999, we had some 23,000 chemicals on the market for which we had no data. All right? Chemicals were just invented, produced, came onto the market. There was no control mechanism, there was no data, there was no nothing. All right? Until we formed the domestic substances list under the powers of SEPA 99, when we found out we had 23,000 chemicals on the market, we could at that point determine that any chemical that came after that date, after the completion of the domestic substances list, became new chemicals that needed to go through a more stringent pre-market assessment before they could access the market. But unfortunately, we already had 23,000 of them in the market for which we had no solid data on toxicity and exposure. All right, so Canada then had to go, like the European Union, like the United States. Canada was not alone. We had to, once we had the DSL and we could carve out new chemicals from old chemicals, we still had to go back and look at the old chemicals, right, and find out which of them shouldn't be on the market, right? And that's what's led us to the things like the Stockholm Convention, to get rid of the dirty dozen, right? Aldrin, dieldrin, PCB, dioxins, furans, and the other elements of the dirty dozen. But until we got those powers, and it was late as 1999, right, that we began to, really truly understand the magnitude of chemical intensification, and we began to put into place regimes to control, keep the worst nasty chemicals off the market, or if chemicals were put on the market, have a regulatory regime built around them that would reduce exposures, keep those chemicals used for the purposes for which they were intended, okay? And the science improved our understanding of the impacts of chemicals on fetuses, children, women of childbearing age, factory workers, chemical applicators, indigenous people, the poor, and the elderly. All kinds of studies were done to improve our knowledge of science. But as this, our scientific knowledge of these issues, that is, but as this was going on, the chemical intensification of the global economy didn't slow down. Our economy today is more chemically intensive than it's ever been in the history of humankind, right? And this is a reality, and this is why, even though climate change these days steals a lot of the limelight, chemicals is still one of the most fundamental and huge environmental issues globally. All right, whether that be the trading of electronic scrap to developing countries that don't have the capacity to manage it, to industrial byproducts, to chemicals traveling in products, and so on. Chemical intensification is huge. All right. So, and we also then, because we began to become more aware of sound management of chemicals issues, environmental monitoring had to become more sophisticated. Other regimes came in, right? Like phase 1, phase 2, phase 3 assessments for properties, ongoing environmental monitoring at the Great Lakes, ongoing environmental biomonitoring of polar bears and other species, just to try to keep track of what's going on out there with chemical, probably more than 27,000 different types of chemicals out there in the market. In the United States, some 52,000. The European Union, same thing. So you can imagine, right? I mean, how do you keep track of all those chemicals? You have to do some monitoring, but even then, monitoring is only modestly effective because monitoring doesn't do a very good job looking at cumulative effects, right? The buildup of chemicals in the environment and then the interaction of different types of chemicals in the environment. And then we began to put into place regimes for monitoring chemical residues on food and so on. Okay, and I'll have more to say about that in a little bit. The chemical intensification of the global economy derives largely from three factors. Okay, the increased volume and a shift of production and use from highly industrialized countries to developing countries and countries with economies in transition. Okay, now this is, in the early days of invention of chemicals, all that was done in what we identify today as the developed countries, right? That's where all the R&D was done. That's where all the science was done. That's where all the chemical big multinationals were located, and so on. And they produced all kinds of chemicals, bulk chemicals, and so on. But over the last 20 years or so, it became much more cost effective to move the large-scale bulk chemical production to lower-cost economies. So a lot of that moved to developing countries that didn't have the commensurate regime to ensure sound management of chemicals. So we ended up getting highly contaminated environments in a lot of developing countries, certainly in China, in India, in Vietnam, in Nigeria, in Brazil, and places where large whole plants were picked up from a developed country and moved down there for the manufacturing of bulk chemicals. The thing is that none of the infrastructure is there to make sure that production of bulk chemicals could be done in an environmentally sound manner. I mean, there's inadequate wastewater control, inadequate infrastructure to prevent spills or other types of issues, inadequate storage of chemical wastes, inadequate storage of chemical products. All of these were the things that we worked on for many years, all right, and for me in some 20-some different developing countries, okay. The second area is the penetration of chemical intensive products into national economies through globalization of sales and use. So now we have, combined with the advent of free trade as all of this was going on, it makes sense to move the bulk chemical production to lower cost production areas. But also free trade brought with it the transfer of products across borders in much higher volumes than ever before in the history of humankind, right? So what traveled with these products is chemicals, single-use plastics or lead in gasoline or mercury in medical devices or any number of different things, right? There's scarcely a product traded these days that doesn't have chemical, including these kind of shirts, right? The shirts that you take out of the dryer and they don't need to be ironed, right? These are treated with nanoparticles, right? To ensure, so virtually all chemical products. So as global trade intensified, not only did the shift in production cause a global intensification of chemicals, but the trade in products encouraged a global intensification of products. I mean, cell phones, classic example, right? Hundreds of millions of these things are sold each year. When they go out of date, where do they go? They're full of chemicals. They're full of heavy metals, plastics, other types of chemicals. How do you dispose of them? And a lot of the problems we had was that, right near the end of life of these cell phones, companies were calling them refurbished and then sending them to developing countries. And of course, in the developing countries, then they become obsolete, unusable, or they break down and it becomes their problem of waste, right? So there were all kinds of tricks of moving this plastic and these other wastes around the global environment too. And that's where the Basel Convention came in as early as 1984, right? And then the third major area of intensification is increased chemical emissions resulting from economic development sectors. In other words, runoff from plants that use chemicals, right? Whether that be oil and gas production or mining or other forms or the manufacturing of paints or these all these companies they do have industrial byproducts, right? They do have runoff. Not everything is, even though regulation tries to prevent these wastes from escaping, of course they escape. Chemicals escape through the stack, they escape through the water pipe, they escape into the soil. You know that from your training in the program. So global intensification of chemicals has just been intensive, particularly since I would say the 1970s. But because the chemical industry didn't really start to boom until after World War II in the 1950s. And it took about 20 years for us to build up a huge legacy of chemical problems. And then by the 1990s, we knew we had a big set of issues here with chemical management, okay? And we still do have big issues with chemical management. One of those be endocrine disruptors, flame retardants, greenhouse gas emissions. Greenhouse gas emissions, methane emissions are chemical, right? So there's a big overlap between chemicals management and climate change issues as well, all right? Low-level ozone, all kinds of chemical-related problems emerge, and that's why we produced a report with UNEP called the Chemical Intensification of the Global Economy. I have that on your reading list, I believe. And I, in context of that, we also did the costs of inaction of pesticide management in sub-Saharan Africa at the same time, all intended to raise the profile of these issues for the eventual negotiation of the strategic approach to international chemicals management. And so the chemicals have become an integral feature of modern life and economies. There's no question about it, right? We all have tons of it in our houses, right? From our computers to our clothing to our cleaning agents to our pharmaceuticals to you name it, right? It's a huge global industry, right? And it's the most globalized of all manufacturing sectors and sits at the top of all manufacturing supply chains. All right, so chemical sector is gigantic, and we continue to chemically intensify our economies each and every day. Okay. These and product trade has become one of the major things because eventually products become wastes, right, and then they have to be managed. If they're not managed properly, then they become a byproduct, right, as well. For example, one of the major problems we had with disposing of old computer components or old cell phones is you ship them to developing countries. You have often children with no protective clothing taking the valuables out, the gold or whatever, the heavy metal out of the product, and then the rest of it would have been incinerated, producing dioxins and furans and all kinds of problems, right? So these products transfer chemicals around the world, but as they remain products, their risk is minimized. When they become end of life cycle management challenges is when those products become a problem. Okay, and those are all kinds of problems. Like I say, textiles, electronics, building materials, toys, you name it, right? I mean, it covers the gamut of the economy. You can scarcely find any product anywhere today that doesn't have a chemical composition to it of one kind or another, or one scale or another, right? I mean, it's if it's a manufactured product. If it's a natural product, maybe not so much. But if it's any kind of a manufactured product, chemicals is a big issue, okay? And because there's so many different products and so many different industrial byproduct situations, right? The management is massively complex for chemicals management. I mean, how do you control all these products? How do you control all these components of that can include chemicals, right? How do you prevent them from getting into the environment in inappropriate ways, right? You just don't. You can't possibly control all these dynamics. So you have to set up regimes that that try to capture, like a hazardous waste management regime, which we'll talk about next week. Anything that could be deemed hazardous. And if you look at the Basel Convention annexes, the list of potential hazardous products is huge, right? And that's an effort to make sure you capture as much as you can so that it goes through a proper hazardous waste management regime, right? So that's why our regulations are set up. There's a hazardous waste set of regulations here, but it's designed to capture like hundreds of different byproduct or hundreds of different waste streams, right, that have hazardous chemical components to them, and move forward, because that's the only way you can do it, because the multiplicity of products, the multiplicity of uses, the multiplicity of exposures is impossible to deal with on a product by product or a situational by situational basis. You need to set up broad regulations that say anything that's on this list, when it becomes a waste, must be captured in such and such a way so it grows into a proper hazardous waste management stream. But we'll talk more about that next week, okay? And trade in products moves virtually all kinds of chemicals, right? Not just it also it moves things that occur naturally in the environment, like lead, cadmium, mercury, and so on, right? So, but we're going to talk about the different types of chemicals in a moment, okay? But keep that in mind, right? Chemical intensification, right? The transport of the movement of large bulk chemical production from developed country where there is the infrastructure to developing countries where there wasn't the infrastructure. The massive ballooning of the use of chemicals in product manufacture, right? I mean, it's everywhere now, right? Chemistry is used on virtually every form of manufactured product today. Almost, it's exceedingly difficult to identify one that doesn't use a chemical either in the manufacturing process or doesn't have a chemical as a constituent part of the product. All right, and then there's industrial byproducts. That's the waste that goes up the stack or out the river or into the land, right? So all of these areas of chemicals management need to be managed, and unfortunately, it's such a huge area that we're scratching the surface, to be quite frank. Okay. And there's different types of chemicals that you should be aware of, right? I mean, commodity chemicals. Those are the big ones that a lot of that manufacturing shifted to developing countries. The commodity chemicals are, oil and gas is a principal feeding stock for chemicals, right? So energy products are converted into what could be characterized as first tier or primary building blocks of chemicals manufacturing. And these are produced in huge volume, and they're typically produced today in developing countries. A relatively small percentage of these commodity chemicals are still produced in developed countries because it's much cheaper to do it in developing countries with all the ramifications of that, right? Bulk chemicals is another thing, because commodity chemicals form the foundation of the chemical industry and therefore are in high demand. They are typically produced in large quantities and they're sometimes known as bulk chemicals. So commodity chemicals, bulk chemicals are often used interchangeably. Another key term is high production volume chemicals. When bulk commodity chemicals are manufactured or imported in quantities of 1,000 tons per year or greater, they may also be referred to as HPV chemicals in legislation or in regulation. And Canada imports a lot of HPV chemicals, right? Because we don't produce many of the bulk chemicals in Canada anymore. Most of our chemical production sector is our specialty chemicals, okay? Then there's the class of industrial chemicals, right? Include commodity chemicals sold by a primary manufacturer of chemicals to other manufacturing industries, including other segments of the chemicals and chemical product sector, and downstream products sold to consumers or to manufacturers of small-scale specialty or niche products, okay? So these are chemicals that are refined a bit, and then they're sold to downstream manufacturers, okay, of specialty chemicals. The guys that produce the cleaning agents where you clean your table or clean your floors, or the guys that produce the chemicals that manufacturers of computer chips need to clean off the computer chips, and thousands of specialty type chemicals are produced out of these industrial chemicals. Okay. And one thing a lot of people don't realize is pharmaceuticals are also becoming a significant environmental issue, right? And a lot of things people also don't realize that pharmaceuticals are a subcategory of industrial chemicals, believe it or not, right? But they're addressed by separate legislation for obvious reasons, right? They're designed to be consumed by humans, right? But they've been receiving increased attention globally as a subcategory of industrial chemicals, owing to studies that have found them in drinking water at concentrations that exceed recommended doses, and they're toxic. And in some instances known as or suspected of estrogenic or gender-bending properties, right? We've seen this. We know that this is the case, right? And we see this with the generation of superbugs, right? Superbugs in the natural environment because of their constant exposure to antibiotics, or fertility drugs, or any number of other things. We're now beginning this because these drugs are consumed by such high volumes, by such a ballooning human population. Natural species are being transformed by these pharmaceuticals. Okay, and you see it from duckbills to any number of other different examples, to the impacts on the frogs, to the impacts on, the early warning species in the natural environment are impacted by pharmaceuticals that they get emitted as waste or get thrown away inappropriately into the natural environment, right? But when we take a pill, it doesn't stay in our body forever, right? We emit it, right? And that goes into the system. And the thing with pharmaceuticals is wastewater plants in North America, in fact anywhere in the world, can't filter out these pharmaceutical wastes. Okay, so these pharmaceutical wastes end up into the natural environment, and that's becoming not only a public health issue but obviously an ecosystem management issue. And then the gem of all gems is the agricultural chemicals, right? And the unique thing about agricultural chemicals is they're explicitly designed to be toxic, right? To kill a species that they consider to be a pest, right? For food production or whatever, right? Or public health control for DDT and for malaria and dengue fever or whatever the case may be. They're a unique class, right? They're explicitly designed to be toxic, but also explicitly designed to be purposefully released to the environment. So the regulatory infrastructure around agrochemicals needs to be quite strict, obviously, right? And there's lots of different classes of these, right? Insecticides, herbicides, rodenticides, bactericides, fungicides, larvicides. It's a huge industry, okay? And some of the recent court cases, right, around glyphosate and the Econex and various types of classes of agrochemicals are examples of the fear that people have around these things and the issues around regulating agrochemicals, okay? And then, of course, there's minerals and metals, naturally occurring chemicals that are used in a lot of different products, right? Mercury, lead, cadmium, etc. And these are highly toxic and highly persistent and bioaccumulative compounds. And so when they're used in products or appear in industrial waste, they're a significant risk factor. And then, as I was saying, we also now talk about chemicals often as existing and new chemicals. So for us in Canada, existing are chemicals that appeared on the domestic substances list when it was formed under the powers of SEPA 1999. And any chemicals coming in after that point are known in Canada as new chemicals. In other words, they had to have gone through a pre-market assessment. Is that pre-market assessment eliminating a lot of the risk factors related to chemicals? Eliminating a sizable amount, but there's always residual risk. There's always cumulative risk in the environment. In other words, monitoring the risk of chemicals is an ongoing, absolutely essential aspect of environmental policy, environmental regulation, policy instruments generally. And this is just a simple chart that kind of lays all this out for you of how chemical classes flow and where they go, okay? So that gives you an idea of what's going on with chemicals. I won't go through that in great detail. So keep in mind that the management of chemicals, you have to manage chemicals as products, right? You have to manage chemicals as constituent parts of products, and you have to manage, chemicals as emissions from production processes, right? So as the complexity of assessing the ever-expanding and chemical intensification of our societies is enormous. It's absolutely enormous. But with scarcity and opportunity cost and the big attention given to climate change, chemical new initiatives in chemicals management have largely stalled. And so one of my pet peeves, and many who work on chemical issues continue to push on this agenda with chemicals. That's why you see the WHO reducing its studies on the effects of chemicals on public health. You find other people working on these issues, trying to keep chemicals at the profile that it was back even, say, 7 or 8 years ago, or 10 years ago when we were negotiating SACAM. But this is the danger of scarcity and opportunity cost. When something as big as climate change comes along and everybody's distracted about it, that doesn't mean that these other significant and huge problems and huge areas of study for environmental protection and public health go away. They don't go away, they're still here. In fact, we're seeing greater and greater chemical intensification of the global economy each and every day. Okay? On that score, I'll let you go, and we'll talk to you next time about hazardous waste management. Take care for now. Bye-bye.